Right, so this screencast is on solving simultaneous equations. We've been working on the substitution method, which is on the screen in front of you now, where typically you've got two equations, linear equations, and they're in the form where you've got y or x as the subject of one of the equations. Really easy then to do a direct substitution, as you can see in this example here. And ultimately, just to remind you, what we're finding is the point of intersection of a pair of lines. Here is a pair of lines. What we're doing is finding that guy there. In this particular pair of lines, it's 2, 3, and I think we've got the drawing of it up there, and you can do that on your graphics calculators as well. Okay, so another example there where you've got y equals 2x. That gets subbed in here for y. So what we're doing, substitution, replacing. Instead of writing y, we write 2x in this equation. So it's 2 times 2x plus x equals 4. That enables us to find x, and then sub back into either equation at the start to find y. Okay, so that's sort of where we're up to. I'm going to look at another method now. Before we do, I'm just going to do one more example using the substitution method, just to make sure it's understood. So an example is find or solve, I should say. Solve the pair of simultaneous equations and in this case I'm going to go with y equals x minus 2 and 3x minus 2y is equal to 7. So there's a pair of simultaneous equations. They're both straight lines, and we're looking to solve them. The simultaneous, remember, at the same time, finding the common solution. So, all right, let's have a look. We've got y equals. Now, that's a classic case of using substitution. So x minus 2 is going to go in here where I see y. I'm going to make that substitution. So that's going to go in there. So I rewrite this as 3x minus 2, not y, but x minus 2. The advantage of that being I now have just one variable to deal with, so 3x minus, excuse me. Now the best way of learning from these screencasts is to use the pause button a lot. Pause, go back, do the question yourself. So if you could do that now, pause it, finish this off, and then you can check your solution. Great way of getting some instant feedback. Minus 2x plus 4 equals 7. So therefore x plus 4 equals 7, and x is equal to 3. Now what we can do is we've got to take 3, that's one of my solutions, and I'm going to put that into either of these equations. Now it's obviously easier to put it in here. Remember, the solution is going to work for either equation, so it doesn't matter which one you put x back into, you will get the same value for y. But I'm going to use the easier one because that's smart. So I'm going to put 3 in here, so y. So substituting in for, therefore, y equals 3 minus 2, which equals 1. So I've got x equals 3 and y equals 1, and that's my solution. Don't forget to go and get y. It's really easy to get x and think you've done the job, because that's what we're used to doing. Okay, we're going to have a look at another method now. It's called the elimination method. And you'll see that this is quite a neat method, especially when equations are written such that we don't have x or y as one of our equations written as the subject. So I'll show you an example of that. So e.g., so this question is going to look like solve. Let's get x plus y equals 5 and 3x minus y equals 3 simultaneously. Okay, so solve that pair of equations there simultaneously. Right, so we're going to find the value of x and y that solves both equations. Okay, how do we do that? Well, we could use the substitution method, but what we need to do firstly is make x or y the subject in one of these equations, then sub it into the other one. Okay, so we could do that. and it wouldn't be a bad exercise to do that, just to check that it works. So that would be one way of doing it. But actually, a quicker way often here is when they're written such that x or y is not the subject, is to use an elimination method, right? And the way we do that is we line up our x's and y's. So we write one equation on top of the other. So I'll show you what I mean. So x plus y equals 5 is one of them. 3x minus y equals 3 is the other. Okay. Now, what we look for now are x or y. Excuse me. We've got a values, coefficients of x or y. If they're the same or they're the opposite, then we can add or subtract to eliminate them. So what we're essentially looking to do is we're looking to add or subtract the two equations together, and the result being one of our variables, x or y, is eliminated. Let me show you how this works. So in this question, I can see that my y and minus y have got the same numerical coefficient. The number out the front is the same. In this case, it's 1. It's plus 1 and it's minus 1 there. Now, if I add those together, 1 minus 1, I get 0. And this is perfectly legitimate. So what we can do with these two equations is we can add them. We can add them in order to eliminate. All right, now let me show you what the result of that is. We just now add x to 3x and get 4x. Okay, x plus 3x is 4x. Y minus y is 0. Now that's the point of this. If we add these together and we've still got x's and y's down here, then we've made a mistake. We've missed the point. So you've got 0 there. I'm going to leave this blank because there's nothing there. 5 and 3 is 8. Look at that. Therefore, x equals 2. How neat is that? X equals 2. Don't forget to go back in and put it up here. Put 2 in here perhaps. Therefore, 2 plus y is equal to 5. And therefore, y is equal to 3. So we've got x equals 2 and we've got y equal to 3. And that solves it by elimination. Okay, and we used the plus method because the signs here were opposite. If they were the same, I would have done a subtraction. Okay, just out of interest, let's have a look at solving it by substitution, just to check which method you'd rather use. Now, this would be quite easy to do by substitution. We could make, say, x the subject of this first equation. So we could go x equals 5 minus y, just taking that y over here. And therefore, in the second equation, we could, rather than write x, we could write 5 minus y. So we could have 3, 5 minus y equals 3. We could do all that. And therefore, 15 minus 3y minus y equals 3. Therefore, we've got 15. So you can see that this is going to work out for us. There's a whole bunch more work. I'm doing this quite quickly, but it's still taking quite a while to get to y equals 3, which is a solution there. And if y equals 3, then x equals 2. So we get the same solution. That's all good, but this was much quicker. So elimination method, when the equations are written in this sort of format where we can line up the x's and y's. Let's do another example. So let's look at solve, and this time I'm not going to make it quite so easy. X minus y equals 4 and 3x plus 2y is equal to 7. Solve them simultaneously. Okay, so let's have a look at these two. So again, the method here would be to write the equations one on top of the other. X minus y equals 4. Now 3x plus 2y is equal to 7. Okay, now in this case, I don't have neither my x's nor my y's have the same coefficient out the front. We don't have the same number. But what I can do is I can multiply one of these equations through by something to create that situation. So I've got two options here. I could multiply this first equation through by 3. If I times the whole thing through by 3, then I'll get 3x minus 3y equals 12. Perfectly legitimate again. It's the same equation as this one here. It's just written differently. Now if I did that and I rewrote this one underneath, 3x plus 2y equals 7. Now I've got 3x and 3x. I can do an elimination by subtraction in this case, because 3x minus 3x give me 0. So I'm going to eliminate my x terms by subtraction. So 3x minus 3x gone, minus 3y minus 2y is minus 5y. Remember, we're subtracting, so it's this minus this. Minus 3y minus 2y, so it's minus 5y. 12 minus 7 is 5. So y is equal to minus 1 when we divide both sides by minus 5. And x is equal to, if we put that back in up here, we would say that x minus 1 is equal to 4. So therefore x is equal to 3. 3 plus 1 is 4. So x is 3 and y is minus 1 is my solution to that pair of simultaneous equations there. So in summary, when we're presented with equations that we can line up, we don't have one as the subject as such, as we did with substitution. It's often quicker, therefore, to go and solve simultaneously by elimination. So we look to line our x's and our y's up, and then we're looking to make either our x's or our y's have the same number out the front. If those numbers have the same sign as they did in the second example here, so that means that 3x and 3x are both positive, I do a subtraction. So I'll take 3x and subtract 3x, nothing. If the coefficients like they did in the first example have the opposite sign, plus 1 and minus 1, then I add to eliminate my y variable there, x plus 3x, and you can see how it rolls through from there. Okay, let's do one more example. What I'm going to ask you to do is do this example. I want you to pause the video, do the example, see if you can figure it out yourself, and then press play and see if we agree. So I'm just going to dig a question out here. Let's have a look at, I'm just pinching it from the book actually. So we're going to do x plus y equals 5 and 2x plus y equals 7. Okay, so we're going to solve, obviously this is solve that pair of equations simultaneously. Okay, now pause and come back. Okay, welcome back. So now let's have a look at what we're going to do here. X and 2x. Okay, I can't do anything with that unless I multiply through by 2 here, but look at this, y and y. Let's do a subtraction. So if we do a subtraction, x minus 2x is minus x, y minus y, gone, 5 minus 7, minus 2. Look at this, x equals 2. Beautiful. X equals 2, y equals, well, if x is 2, y must be equal to 3, because 2 plus 3 equals 5. So there's my solution. Okay, get the examples out, take the notes down. Hopefully you've had a little success there and you've figured it out. If not, there'll be a chance in class to ask questions, but essentially we'll be ready to get stuck into the next exercise, which is exercise 1J. I'll see you soon.